People of shockwaves. Sir Frederick Augustus Abel, the chemist who revolutionized explosive science. In the Victorian era, explosives were deadly gambles. Gunpowder detonated spontaneously in storage. Nitroglycerine killed Nobel's own brother. Mysterious explosions tore through coal mines and flour mills with no explanation. One British chemist would dedicate his life to understanding these violent forces, establishing the scientific foundations of modern explosive chemistry. This is the story of Sir Frederick Augustus Abel, the first Baron Abel, the man who made the science of shockwave safe. Frederick Augustus Abel was born in 1827 in Woolwich, southeast London, the eldest son of Johann Leopold Abel, a music master of German descent living in Kennington. Young Frederick's education bridged two worlds. He attended the prestigious Johanneum Gymnasium in Hamburg before returning to England to pursue chemistry. Abel studied at the London Polytechnic Institute and the Royal College of Chemistry, initially researching aniline derivatives. But in 1849, at age 22, his career took a decisive turn when he began offering instruction in practical chemistry to artillery officers at the Royal Military Academy in Woolwich. His brilliance was quickly recognized. In 1851, Abel succeeded Michael Faraday, one of history's greatest experimental scientists, as professor of chemistry at this prestigious institution. He was only 24 years old. In 1854, Abel became ordnance chemist and simultaneously Great Britain's first chemist to the War Department, a position he held until 1888. He later also served as chemical referee to the British government, making him the nation's ultimate authority on explosive chemistry. Between 1856 and 1861, working with Sir Charles Wheatstone, the telegraph pioneer, Abel investigated the applicability of electricity to military purposes and explored the detonation of explosives by electrical means, laying groundwork for controlled demolitions. But the greatest challenge was gunpowder, a nitrocellulose explosive far more powerful than gunpowder, but terrifyingly unstable. Storage facilities had been destroyed by spontaneous detonations. Abel attacked the problem methodically. In 1866, after years of experimentation, he developed a revolutionary process. By reducing gunpowder to a fine pulp, it could be worked and stored with little danger. The pulp material released internal stresses, preventing spontaneous detonation. This breakthrough made gunpowder practically usable for the first time. In 1867, Abel tackled a controversial question: how fast did nitroglycerine detonate? The detonation velocity of this unstable liquid was subject to great controversy among scientists. Abel designed careful experiments using tubes of precisely 3 millimeters in diameter. His measurements revealed a detonation velocity of 1,525 meters per second, over 4 times the speed of sound. This fundamental data explained how explosives generated shock waves and transmitted destructive energy. Between 1875 and 1880, Abel collaborated with British chemist Sir Andrew Noble in groundbreaking research. Together, they investigated the nature of chemical changes that result from firing explosives and actually measured the temperature of fired gunpowder, revealing the thermodynamics of explosive decomposition. In 1875, Abel invented the Abel heat test for checking the stability of cordite and other nitroglycerine and nitrocellulose explosives. The test involved heating a sample in a test tube under rigid temperature control, with special paper suspended over the explosive. The time taken for the paper to develop a brown color indicated stability. This became a standard quality control procedure still referenced today. In 1889, Abel achieved his crowning accomplishment. Working with James Dewar, a Scottish professor of chemistry at Cambridge University, Abel invented and developed cordite. This new propellant was a carefully engineered mixture made from purified ingredients, nitroglycerine, nitrocellulose, and petroleum jelly. The petroleum jelly acted as a plasticizer, creating a stable form. Crucially, cordite was smokeless, eliminating the dense clouds that had revealed artillery positions since gunpowder's invention. Cordite was adopted as a standard explosive of the British Army and proved of vital importance in the First World War, giving British forces a significant tactical advantage. In the early 1880s, Abel investigated catastrophic disasters at the Seaham Colliery in Durham, studying the causes of fire-dam explosions and their connections with the presence of finely divided coal dust in the air. His research revealed an overlooked phenomenon, dust explosions. When combustible particles are suspended in air at the right concentration, they can propagate explosive combustion with devastating speed. This work also shed light on previously inexplicable but disastrous explosions in flour mills, where fine wheat dust had caused mysterious catastrophes. Abel's findings led to improved ventilation and safety protocols that saved countless lives. In 1883, Abel sat on the Royal Commission on Accidents in Mines, helping establish safety regulations based on scientific understanding. Abel was knighted in 1883 and became the first Baronet Abel in 1893. He received the Royal Medal in 1887 for his research on explosives and the Bessemer Gold Medal in 1897. His leadership shaped British science. He served as president of the Chemical Society from 1875 to 1877, second holder of the presidential chair of the Institute of Chemistry from 1880 to 1883, and chaired the Committee on Explosives from 1888 to 1891. Abel also presided over the Institution of Electrical Engineers, the Society of Chemical Industry, and the Iron and Steel Institute. He participated in founding the Imperial Institute in London. In 1888, Cambridge University made him Doctor of Science. Sir Frederick Augustus Abel died in 1902, leaving behind a transformed world. He measured detonation velocities, invented stability tests, discovered dust explosion mechanisms, and established principles that still guide explosive science. Every safely manufactured propellant, every controlled demolition, every mine disaster prevented, all trace back to Abel's meticulous research. He didn't just study shock waves. He revealed their secrets, measured their power, and taught humanity to harness them safely. Sir Frederick Augustus Abel, the chemist who turned destruction into science.